Hello everyone. Welcome to our comprehensive video guide on exit exam solution tailored for BSc graduate students. This video contains exam solutions or simply detailed solution on mathematical courses like linear algebra, calculus, differential equations, numerical analysis, algebra again, which is group theory, financial mathematics, calculus with several variables, and others. So directly, let's proceed to the first question. Question number 1 says, which of the following vectors are not linearly independent? We know that in order to answer such a question, what we have to know here is that the criteria that a vector of simply two or more vectors to be linearly dependent or independent. And you know, a set of vectors is linearly dependent if one and only if one vector can be written as a multiple of the other, or if any of the given vectors is returnable as a linear combination of the others, so that will be a sufficient condition for the given vectors to be linearly dependent vectors. So when we see option B here, we know that if we let V1 to be the first one, that's simply this one is V1, this is V2, that is 2, 0, minus 1, and 2 minus 2 to be V3. We know that the V1, that's simply 1 minus 1, 1, and this one. So that V3 can be, that is 2 minus 2, 1 can be written as a combination or simply multiple of V1, that is 1 minus 1, 2, because this one that's simply 2 minus 2, 1 can be obtained from this one by multiplying V1 by 2, which is a scalar. So that in this case, V3 can be written as V3, the linear combination of the other two, that's simply 0 times V1 plus 2 times V2. So that in this case, the set P is not linearly independent. That means they are linearly dependent vectors. Therefore, the solution or simply the answer for this question will be B. Second question, which of the following type of matrix is not triangular matrix? You know what triangular matrix is. First case, a matrix, for a given matrix to be triangular, it needs to be that of a square matrix having the same number of rows and columns, so that a matrix is said to be triangular if it is either an upper triangular or lower triangular matrix. You know that all diagonal matrices, including scalar matrix means type of matrix with some scalar quantities or simply scalars on the diagonals, but the other components are zero. Identity matrix, a square matrix whose diagonal components are exactly equal with that of 1, but the other components are still 0. And zero matrix, whenever a square matrix is zero matrix or simply zero matrix means a matrix whose every components are 0. So that they are technically both upper and lower triangular matrix. That means the scalar matrix, identity matrix, diagonal matrix, and this one that is they're all simply linear matrix are both upper and lower triangular matrices. So that in this case, in many contexts, this is a trick question as all options are triangular matrices. Therefore, the answer for this one could be all the provided option. That means just it is a bonus. That means scalar matrix by itself is a triangular matrix. Identity matrix is also triangular. Zero or simply null matrix is also diagonal, or triangular matrix. Diagonal matrix even itself is a triangular matrix. Therefore, there is no any matrix which is not probably not a triangular matrix. Therefore, all the options are triangular matrices. Question number 3. It is a question on calculus that simply for a limit of a function, a limit of the rational function that's simply the square root of x squared plus 10 minus the square root of 19 over x minus 3 is equal to blank. The options are this one, that is 3 over radical 19, 6 over radical 19, 0 and doesn't exist. The given limit that's simply the function here at whenever x approaches 3 could be, that is the denominator, that is simply the square root of x squared plus 10 minus the square root of 9. Directly, if we substitute 3 in the place of x here, we have 3 squared, that's simply 9 plus 10, 19. The square root of 19 minus 19 would be 0. And again, the limit of x minus 3, that's the denominator of this rational function, at 3 is also 0, so that this will have an indeterminate form, that is 0 over 0. Therefore, applying L'Hopital's rule, that is, if we know that L'Hopital's rule stated that if the limit of the given function, that's simply this one, that is limit of x when x approaches a is equal to the limit of g of x at a, if both are 0, then the limit of f of x over g of x will have an indeterminate form, that's simply 0 over 0, so that in this case, the limit of this fraction could be the same as the limit of the derivatives of the corresponding function, that is f derivative of x over g derivative of x. So that if the limit of this function is existing, so that the limit of this function could be directly taken for the limit of f of x over g of x whenever x approaches a. Therefore, the derivative of the numerator, that's simply this one, that is the square root of x squared plus 10 minus 19 could be, we have to take the exponent, that's 1 over 2 the coefficient here. We have x squared plus 10 minus 1, that's simply 1 over 2 minus 1, which is negative 1 over 2. That's chain rule, times twice of x, which is the derivative of x squared, that means, so that this is equivalent with x over the square root of x squared plus 10. And similarly, the denominator, that's simply derivative of x minus 3 is 1. Therefore, evaluating at x equal to 3, we have 3 over this one, that's simply 3 squared plus 10, which is equal to 3 over 19. 3 over 19. Therefore, the limit of the given function could be, that is the answer, which is A. Question number 4. Let f of x equal to x squared plus 2x plus 1. Then we're asked just to find f inverse of 9, f inverse at 9. That's the derivative of f inverse of 9. Then the alternatives are a is 1 over radical 6, 1 over 6, 1 over radical 3, and 1 over 3 are given. So in order to select the right derivative of this one, the inverse of the given function at this one, we have the formula, that's simply this one. Do you remember? The derivative of f inverse at y is simply exactly equal with that of 1 over the derivative of f at x, whenever f of x is equal to y. Therefore, for x squared plus 2x plus 1 is equal to 9. This implies x plus 1, which is a perfect trinomial, that is x plus 1 squared is equal to 9. This implies x plus 1 is equal to 3. That means the value of x here is 2. That means when we substitute 2 in the place of x here, that is f of 2 is equal to 9. Therefore, if f of 2 is 9, so that f inverse derivative of 9 is exactly equal with that of 1 over f derivative of 2. So that if derivative of x is equal to x plus 1, this implies f derivative of 2 could be 2 times 2 plus 2, which is 6. Therefore, f inverse derivative of f inverse at 9 is equal to 1 over 6. That is 1 over f derivative of x, or f derivative of 2, because f of 2 is 9. Therefore, the exact answer for this one could be, that is B. Okay, the next question would be the evaluation of that of the integral. Find the value of the integral of cos square x times tan cubed x dx is blank. And the alternatives are this one. So when we do the solution for this one, we have this thing that's simply the integral of x squared x times tan cubed x means, because tan is the ratio of sine and cosine, so that it could be sine cubed x over cos cubed x dx, which is equal to, further, if we simplify this one, for example, that is cos square x can cancel cos square x here, and we are left only one cos x, so that we have the integral of sine cubed x cos x dx. And then the equivalent with, but the numerator that simply sine cubed x can be written as, that is, we have sine x times sine square x. Then by using trigonometric identity, sine square x is 1 minus cos square x. So it could be sine x into 1 minus cos square x over cos x dx. Then distributing sine x over 1 minus cos square x, we have that is sine x times 1 is sine x over this one, that's simply cos x is tan x. And when we multiply this one, that's simply sine x, cos square x over cos x can cancel this one, and we have minus sine x cos x dx. Then the integral of this one, that is, we can distribute the integral over this, because integral of the sum or the difference between two functions, it is just the integral of tan x dx minus the integral of sine x cos x dx. Also, applying integration by substitution or using integration by substitution for both the integral of tan x dx and sine x cos x dx, let's assume that is equal to cos x. So that in order to determine dx here, then the derivative that is taking the derivative of both sides of this, that is u cos x, we have du is equal to the derivative of cos x, which is minus sine x dx. Then substituting these two, we have on the second one, or simply especially for this one, we have sine x equal to minus du. So that when we substitute this one here and integrate them, we will obtain minus ln the absolute value of cos x minus 1 over 2 cos square x plus any constant that is c. Because here we have tan x means the ratio of sine x over x dx, then we are letting u to be cos x, so that dx could be, I mean, the numerator that sine x dx could be minus du, therefore it could be minus ln of cos x minus the integral of this one is minus 1 over 2 cos square x plus c. Therefore, the integral of this one is this thing. Therefore, the answer for this one could be, that is A, which is minus ln of absolute value of x plus 1 over 2 cos square x plus c. The next question. Question number 6. If the interest rate per year is 16% and the compounding occurs every quarter, then the interest rate for compounding period is A 0.04, B 0.004, C 0.4, and D is 40. Here, the annual rate R is equal to 16%, that is 16% means 0.16. And the compounding period per year, that is M, could be 4, that is simply quarterly. And the periodic rate, that is I is equal to R which is the annual rate divided by the compounding period per year, that is M. So that could be 0.16, because we are just already, we have here, that is already this one, and the compounding, that's M is 4, so therefore 0.16 over 4 could be 0.04. So that the answer for this one could be, and that is A. Question number 7. Which of the following vector is perpendicular to both? A is equal to A is equal to 2 minus 3 1, and B is equal to 1 2 minus 4. The alternatives are A 4 0 1, B 10 9 7, and 3 2 1, and lastly D we have 0 10 9. We know that in order to determine a vector which is perpendicular to both A and that of B, the only vector which is perpendicular to both A and that of B could be the cross product of the two vectors, or the negative of the cross product of A and B. Therefore, the cross product AB yields a vector which is perpendicular to both A and B. Therefore, the cross product of the two given vectors are, using this notation, that is ijk, we have the first vector, that's simply vector A, and this one is B, so that the product could be, if we expand along the first row here, it is just I multiplied by, if I delete this one in the first column, we have minus 3 times minus 4, which is positive 12, minus 2 times 1, that's simply 2, minus minus j, that's simply minus j into, if I delete this row in the second column, we have 2 times minus 4, which is minus 8, and 1 times 1, that is minus 1, plus k into, if I delete this row in this column, we have 2 times 2, which is 4, minus minus of 1 times minus 3, which is minus of minus 3, that is positive 3. Therefore, the is equivalent with 12 minus 2 is 10i, plus minus 8 minus 1 is minus 9, but this one is negative, so that it becomes positive 9j in the j direction, plus this one, that is 4 plus 3, which is 7 in the k direction. That means, this means in component, or simply in the form of ordered pair, or simply triplets, that is 10, 9, and 7. Therefore, the solution, or simply the answer for this one could be, that is B. The next question, the solution of the ordinary differential equation given by the second derivative of y plus 1 over x times the y derivative minus 1 over x square y is equal to 0 for x greater than 0 is ax the power of r, whenever r is a constant, e the power of xr, r is a constant, x the power of 1 over r, whenever r is a constant, and x the power of 1 over r is a constant. I think these two are similar alternatives. And therefore, we know that the given ordinary differential equation is a Cauchy-Euler equation because the power of x matches the order of the derivative. That means if we multiply both sides of this equation by x squared, we have x squared times second derivative of y, x times y derivative minus minus y is equal to 0, so that we have x squared y second derivative, so therefore the exponent of x is 2, and the order of the derivative of this one is, that is 2, so that it matches. For equation of this form, that is x squared y plus x y prime plus py is equal to 0, where we have to assume, or simply we can assume that the solution of the form y is equal to x the power of r. For the case, the ordinary differential equation becomes, that's simply this one, multiplying both sides of this one, just x squared, we have this one, and that is x squared y second derivative plus x times y derivative minus y is equal to 0. Hence, y is equal to the power of r will be the form of the solution for this differential equation. Then if we let y to be x the power of r, the first derivative of y with respect to x would be r times x to the power of r minus 1, and second derivative would be y second derivative is equal to r into r minus 1 times x to the power of r minus 2. Then just to have the solution or simply the values of r, you can substitute in the place of the derivatives here, and we can solve or simplify the value of r there. Anyways, the solution form of the given ordinary differential equation is y is equal to x to the power of r. I think the solution or simply the answer for this one could be A. Next question, the general solution of the ordinary differential equation x squared y second derivative plus 2x y derivative minus 6y is equal to the raise, which is similar to the previous one, but here we are asked just to have the general solution. Therefore, in order to have the general solution again, the given ordinary differential equation is Cauchy-Euler equation again, which is similar to the previous one. And therefore, let's assume that the solution has the form y is equal to x to the power of r. Then, if y is equal to x to the power of r, then y derivative is this one, and second derivative of y with respect to x would be r into r minus 1 times x to the power of r minus 2. Now let us substitute this one, that's simply y is y prime, y double prime, that is r times x to the power of r minus 1 in the place of y prime here, and r into r minus 1 times x to the power of r minus 2 in the place of y second derivative within the original equation. Then substituting this one gives this one, that's simply r into r minus 1 times x to the power of r minus 2 times x squared plus 2 times r times x to the power of r minus 1 times x minus 6 times y is equal to 0. Then if we multiply, for example, here we have x to the power of r minus 2, x to the power of 2. So because they do have the same base, so that if we add the exponent together, the sum of r minus 2 plus 2 will be r. Here also r minus 1 plus the exponent of x, that is 1, is still r here. And we have this one, sorry. Here in the place of I, x to the power of r must be substituted. This y must be replaced by x to the power of r. So that in each term, we have the factor x to the power of r. That's this, simply this one. R into r minus 1 times x to the power of r to r times x to the power of r minus 6 times x to the power of r. Then, if we assume that x is non-zero, so that when we divide both sides by x to the power of r, since it is non-zero, then we'll obtain the function that is r into r minus 1 plus 2 r minus 6 equal to 0. Then simplifying this one, we have r squared plus r minus 6 is equal to 0. So that solving this quadratic equation, we have the value for r to be 2 or r is equal to negative 3. Therefore, the general solution for the ordinary differential equation could be just the combination of this one, that's simply y is equal to x to the power of r whenever r is 2, and that of r is equal to minus 3. So that it could be, I think the answer could be this one, that's simply c1 times x to the power of minus 3 plus c2 times x to the power of 2. For example, the first one can never be this one because the value of r is not 1. That's simply the value of r is either 2 or minus 3. So that's the exact answer for this question could be b, which is 1 times x to the power of minus 3 plus c2 times x to the power of 2 will be the general solution of this Cauchy-Euler ordinary differential equation. Okay, next. The assumption in calculating annuity is that every payment is equal and different, nominal, marginal. So in order to answer this question, we must be clear what an annuity first. We know that an annuity is defined as a sequence of equal payments made at regular intervals. And it is defined as a sequence of equal payments made at regular intervals. So that's just to simply just to make this payment made at a regular interval, so that this equality is fundamental to using standard annuity formula. Therefore, the answer for this one could be equality. That means if there exists equality here, so that the equal payment will be guaranteed there. Next question, let f of x equal to sine of cosine x, then find f derivative of x. Then the alternative that this one. So in order to find the derivative of this function with respect to x, using that of chain rule, we have d pi dx of sine of u is equal to cosine of u times u derivative whenever u is equal to cos x. Just substitution like that of integration. Therefore, if we back substitute or simply this one, that is u derivative minus x, therefore f derivative of x is equal to cosine of u, but u is cosine of x, that is cosine of cos x, times minus sine x. Therefore, it's just minus of cos x, cosine of x, sine x. Therefore, the answer could be minus sine x cos x, minus sine x cosine of cos x, that is simply b. This could be the solution. Next, what is the real rate of interest if the nominal rate is 10% and the inflation rate is 5%? The alternatives are 4.3%, 4.8, 5.3, and 5.8%. So you think that a Fisher equation which relates nominal interest rate, that is, which is symbolized by I, real interest rate represented by R, and inflation rate, that's simply pi, which is given by I is equal to that's simply these are the givens, and the formula for this one, that is a Fisher equation, could be 1 plus R is equal to 1 plus I over 1 plus pi. Whenever R is the real interest rate, I is the nominal interest rate, and pi is just the inflation rate. But what we are given here is the interest rate is given to be 0.1 or 10%. The inflation rate is 5%, which is 0.05. So that in order to find R, which is the real interest rate, we have to use this formula, that is 1 plus R is equal to 1 plus I over 1 plus pi. Then substituting these values using or simply within this formula, we have 1 plus R is equal to 1.1, that's simply 1 plus I means, that is I in this case, I is given to be 0.1, and we have 1 here, that is 1 plus 0.1 could be 1.1 or simply 1.0 divided by 1 plus pi. Pi is given to be this one, therefore 1 plus pi could be 1.05. Then the fraction or simply the quotient of this one, 1.1 over 1.05, could be approximated as 1.0476. And this could be rounded to at this one, that's 4.8. That means it is just this 1.48, and This could be this one that's simply 1.0476 is identical with the 1.8 r. So in order to find the value of r here, we have to subtract 1 from this. So that what's left here is only 0 point r could be approximated as 1.0476 minus 1, which is 4.76, and it could be rounded to 8%. So that the answer for this one could be, that is B. Yeah, this is B. Next question. The equation 1 minus x squared y double prime, or simply y second derivative, minus 2x times y derivative plus 2 into 1 plus xy is equal to 0 is known as A. Chebyshev equation, B. Bessel equation, C. Legendre equation, Bernoulli equation. The coefficient 1 minus x squared for y second derivative and minus 2x for y are the hallmark of Legendre type differential equation. The Legendre type differential equation, that is 1 minus x squared, the coefficient of this one, that's simply this thing. We have minus 2x for the coefficient of y derivative. Therefore, they are fundamental for Legendre type differential equation. Therefore, this is a Legendre type differential equation. Therefore, the answer for this one could be C. So, as an exercise, or simply just to refresh you, just to test yourself, please justify what, or simply the form of Chebyshev equation, Bessel equation, and Bernoulli equation. Next, let a parabola antenna takes the equation x squared is equal to 160y. Then what is the area between x squared is equal to 160y, y-axis, y is equal to 2, and y is equal to 4. The alternatives are this one. So in order to determine the area which is bounded by using that of these 4 equations, we know that the area, or simply the surface, is bounded from above by y is equal to 4, and from below y is equal to 2. But bounded in between that of 4 vertically and horizontally, and it is bounded by the y-axis, the vertical axis, and the curve of x squared is equal to 160y. So we have here x squared is equal to 16y, and this implies we have the value that's simply x is equal to the square root of 60y, that is just taking the square root of both sides of this equation. Therefore, the area could be the integral vertically, that's simply from 2 to the other 4, the square root of this one, that's the square root of 160y dy, which is equal to the square root of 160 is a constant, so which we can take out from the integral, and so that the integrand will becomes the variable integral. That means only the square root of y. Therefore, the integral of the square root of y could be we can bring 1 over 2, or simply here, that is y the power of 1 over 2 plus 1 over 1 over 2 plus 1, which is y the power of 3 over 2 over 3 over 2. Then taking the reciprocal of the denominator here, we have 2 over 3 become the coefficient here. Whenever the limit of integration is from 2 to the 4, then directly applying or simply substituting the upper and lower limit of integration gives the area to be 2 over 3 into the square root of 160 into 4 the power of 3 over 2 minus 2 the power of 3 over 2, which is equal to 2 over 3. That 4 the power of 3 over 2 means 8. 2 the power of 3 over 2 means 2 radical 2. Therefore, the area could be 2 over 3 times the square root of 180 into 8 minus 2 radical 2, that is, which is identical with this one, that's simply C. So therefore, the answer could be C. Next, An investment of 9,000 today will yield 10,000 after 1 year. What is the net present value if the interest rate is 10%? Here are the alternatives: 71 birr, 81 birr, 91, and 101. What is given here is the initial investment is 9,000 birr, which is an outflow. And the future value, that's simply just after the investment, it is expected to yield 10,000 birr after 1 year, which is an inflow again. Then the discount rate is 10%, or that is 0.1. So that using NPV, that is net present value formula. The formula is net present value is equal to present value, that is the inflow minus the investment, the initial investment. That means so that the present value could be this one, that's simply 10,000 divided by 10,000 divided by 1.1 minus 9,000 minus 9,000. Therefore, this could be that is 9,090.91 minus 9,000, which could be 90.91, and this could be just approximated to 91. So that the alternative, that is the best answer for this question, could be, that is C. Next question, it is again limits. The limit of 1 plus sine of 4x, the power of 1 over x equals e the power of minus 4, e the power of 3, e the power of minus 3, and e the power of 4. You know that this limit has a form of 1, the power of infinity limit form. That means directly if you substitute, or simply 0 from the right side here, if you substitute 0 here, 4 times 0 from the right could be 0, sine of 0 is 0, 0 plus 1 is 1, and the exponent, the limits of 1 over x when x approaches 0 from the right side is infinity. Therefore, it has 1 the power of infinity form. So that in order to determine the limit of this function, whenever x approaches 0, we have to convert this form, that is 1 over 1 the power of infinity form, either 0 over 0 or infinity over infinity indeterminate form. So to do this, let's assume that the limit of this function at 0 from the right side is y. Then let us take the natural logarithm of both sides of this equation. So when we take the natural logarithm of both sides of this equation, we have ln y is equal to ln of 1 plus sine of 4x over x. That means ln of 1 plus sine of 4x, the power of 1 over x, means we can bring, using that of laws of logarithm, that means we can bring the exponent at the coefficient here, so that 1 over x means it is just the ln of 1 plus sine 4x over x. And then if you take this one, that is ln of 1 plus sine 4x over x, the indeterminate form for this one could be, the above could be, if you directly apply 0 from the right side, they hit 0, that's simply sine of 0 is 0, 0 plus 1 is 1, ln of 1 is 0. Again, this one, that's simply x is also x at the limit of x, whenever x approaches 0 from the right side is also 0. Therefore, this rational function has a 0 over 0 indeterminate form. So that using, or simply applying L'Hopital's rule, the limit of this one, that's simple ln of 1 plus sine of 4x over x, whenever x approaches 0 from the right side, is equal to the limit of the derivative of the denominator over the derivative of the denominator. The derivative of the denominator could be, it is ln, so that 1 over 1 plus sine of 4x, and applying L'Hopital's rule, we have the derivative of 1 plus sine of 4x could be cosine of 4x times 4. So that we have 4 times cosine of 4x over 1 plus sine of 4x over 1. That's simply this 1 means the derivative of the denominator, which is x. So that the limit of this rational function whenever x approaches 0 from the right side is 4. But this one that's ln of this one, or simply this, is equivalent to this one that's simply ln y. That is ln y is equal to 4. If ln y is equal to 4, because we are starting by letting y to be the limit of this function, so that in order to determine y here, let us take or just raise to the exponent that's simply e. So that's y is, which is equal to the limit of the original equation is equal to e the power of 4. E the power of 4, so that the answer for this one could be, that is D. Next, which of the following mapping T is not a linear transformation from R cubed to R square? Linear transformation, that is, we have this for transformation. So in order to distinguish which mapping is not linear or simply linear transformation from R cubed to R square, we have to know what a linear transformation or simply criteria that must be satisfied by a linear transformation. We know that a linear transformation must satisfy the image of this one that's simply 0 under T must be 0. So when we measure this one that's simply, for example, A here, T of 0, 0, 0 means, that means in R cubed, this could be converted into 0 minus 0, that is 0, 0 minus 0, 0, so that T of 0, 0 could be identical with 0, that simply it can be satisfied. So that this one mapping, that simply the mapping x, y, z is equal to x minus y and x minus z is linear, that means. Similarly, if we check for T of 0, 0, 0 could be 0 plus 0, that's simply every variable is 0, that could be 0, 0, so that this is also linear. But when we take this one, whenever x, y, and that of z are 0, the output or simply the image could be 1 plus 0, that's simply 1, and y is 0, so that becomes 1, 0. So that T of 0 is different from that of 0, so that and this one that's simply different from that of 0, 0. Therefore, the mapping under alternative C is not linear, so that the answer for this one is 0. I mean C. Next, identify the error types for the following approximations. Error type. We have different error type in numerical analysis or simply numerically. So for example, this one, we have this one that is simply, that's an expansion. So we have a truncation error, or simply ignoring higher order terms. That means this f of x, y could be approximated as f of x plus h times f derivative of x, plus there are terms here, that is h squared times f second derivative of f at x plus h cubed times third derivative of f, like this. Therefore, the terms from h squared times second derivative of f of x will be ignored here, and the error which is obtained by ignoring some higher order terms are said to be truncation error. The second one, this could be, that is 3.75697 is approximated to 3.757. So that this could be obtained from this one by rounding of 9 to the nearest number, that's simply 6. So I think it is rounding error. C, that's 3.756 is obtained from this one. So that it is just 7.569, that is 7.56. So that 9 and that of 7 are ignored. So it is just like the first one, it is chopping or truncation error. And the last one, height is equal to 8 plus or minus 0.05 5 centimeter. Therefore, the error which is created here could be, it is an absolute error. It is an absolute error. That is an error which is bounded in between the smallest and the highest one. So that truncation, rounding off, chopping, and absolute error could be the error types of this one. Next, conditions for the convergence of fixed point iteration scheme. Whenever the iterative formula is this one, that is xn plus 1 is equal to g of xn to p, and then the first one is the absolute value of g of x less than 1, the absolute value of g of x greater than 1, the absolute value of g derivative of x is greater than 1, and the magnitude of g derivative of x is less than 1. We know that for a fixed point iteration to be convergent or simply to converge, just the derivative of the iterative function, the iterative function in this case is g of xn, or simply g of x, must be less than 1 in magnitude. So that the alternative which satisfies this condition, or simply this explanation, could be this one, that's simply the magnitude of g derivative of x whenever g of x is an iterative scheme or simply formula for this method, so that the answer could be a D. Next, given as 3 by 3 matrix with two matrices, that means determinant of A is equal to 2 and the determinant of B is minus 3. Then which one of the following is incorrect? We have to select the incorrect one. The first one, the determinant of twice of AB is equal to minus 48. The determinant of A inverse is 1 over 2, and others are given here. So we have to know the relationship that exists in between the determinant of two matrices and the determinant of their product, the relationship that exists in between their inverses and transposes. For example, the first one, the determinant of twice of AB, sorry, there must be equality here. The determinant of twice of AB is equal to 2 times, I mean to the power of 3, whenever 3 is the order of the given matrix. Then that means whenever we multiply any of the matrix by a certain constant, that's simply k, so that the determinant of the original matrix will be increased by k the power of n, whenever n is the order of the given matrix. So in this case, the determinant of twice of AB is equal to 2 cubed the determinant of A times determinant of A, so that to the power of 3 is 8, the determinant of A is 2, the determinant of B is minus 3, so that this is minus 48, which is correct. But we are asked just to select the incorrect one. B, the determinant of A inverse is equal to 1 over the determinant of A. Sorry, here we have to include the equality. Here we do have equals. Here we do have also 1 over equals. That means the determinant of A inverse is equal to 1 over the determinant of A. That the reciprocal of the determinant of A, but this could be holds true whenever the determinant of A is non-zero. So, but the determinant of A is given to be 2, so therefore it is just 1 over 2, and the alternatives also say, therefore this is right, or simply it is correct. C, the determinant of A transpose. We know that if the determinant of every matrix and its transpose are the same, that means changing the rows and the elements of the given matrix will not affect the determinant of the matrix. But in this case, the determinant of A inverse, A transpose given to be minus 2, but the determinant of A is 2, so that 2 is different from that of minus 2, therefore this could be incorrect one. the incorrect one. The last one, that's the determinant of AB is equal to the determinant of the product of two matrices is the same as the product of the determinants of the individual matrices. Therefore, 2 times minus 3, which is minus 6. This is also okay. Therefore, the incorrect one is here to be. That is C. Yeah, the answer is C. That is the determinant of A transpose equal to minus 2. It must be positive 2, which is identical with the determinant